So everything so far is looking pretty good. I have to give you props. Looks like you're utilizing some lovely Mighty Bites. Great way to hold your material, especially if you're doing something with a pallet setup. So as I'm assuming, Elijah's going to go ahead and quick swap these out of his machine. So let's jump over to the manufacturing. Now, in this case, he's yet to give me a setup, which only makes my life better. But as you guys are going to see here, there's a lot of ways you could actually program something like this at home. As you're going to see, I'm going to go ahead and create my setup. Now, instead of getting too wild and too crazy with everything right off the start, I'm going to go ahead and set up my XYZ looks good. I am going to base everything off of his design tree. Now, we're going to see which ones we got here. It looks like he's got his base. He's got lures with stock. Now, this is where we find out real quick, did he organize this properly? And it looks like he did. So we're going to start with the front one. And then from there, we're going to go ahead and throw our stock on here from solid. Now, I do need to figure out which one the stock is. And as you guys are probably questioning right now is why is it that I'm going through and more or less machining just one of these? Now, the reason why I'm doing just one is based on a first setup scenario. I am going to pattern each additional one from here. Now, the importance of components right now is when you guys are going to see this pattern take effect. So let's get some tool paths on here. All right, right off the rip, I'm going to go in. Let's see what do we have. We have a 3-axis mill rough situation. As you are now seeing, we're decking off the top of our part. I'm going in and I'm using 3D adaptive clearing to rough things out. And then lastly, we do have 3D contour here. Probably not the best of choices, but as you're seeing, this worked out pretty well for this first part. So from this, if I take all of my tool paths using Control or Shift, again, I'm going to look at doing a new pattern. Now, what this pattern option I'm going to use is called component pattern. Because Elijah built this out the proper way and made each individual body here its own component, it makes this very easy for me to set up. So if I go in and I pick my part model here, or if I pick it over here on the left, what you're going to notice that quick, it has duplicated to each additional component that is similar. So again, this is very nice to be able to do. Now, you can order these a lot of different ways. Maybe Elijah wants to just run the very first one fully. I could say preserve order, which means it's going to face, rough, finish, chamfer, drill, and then move on to the next one. Now, a few other ones is in the event that you want it to actually go through and use the same tool for both roughing and finishing, kind of like I'm doing down here if I get scrolled down to it, is you can see I'm using tool 2 to rough, and then I'm using tool 2 to also finish. I may actually want to rough, 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 then finish, 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 which means we're going to keep the operation order. Yes, we'll jump back and forth a little bit more, but it's not a huge deal. And then lastly, order by tool just means, if you're using tool 2 a bunch, stay on the same part till we go to the next one, right? So again, utilizing that pattern technique, I'm picking up what he's trying to do in different locations. So again, from there, as you guys can see, we're going to have to go ahead and regenerate that roughing. But as you're going to watch me work through this even more, we do have things like fixture detection now causing me some problems. And again, this is why we make these free support Fridays. I see even more of you guys out there. Everybody is speechless in chat this week, but we did do videos on this as well. So let's get our tool paths back up here to the top, and let's go in and troubleshoot our tool path. So by default, utilizing a fixture in our setup, we've actually changed how a void machine surface works from the older style inside of Fusion. So if I wanted to specifically for this tool path, override what I would call a global or at my setup level setting, I could easily come in and say, axial wise, which means Z in this case, I want to get 150 thou closer. So again, as I'm going to plug in negative 150, you're going to notice we're at 196 versus 046. And just like that, that toolpath is now going to reach down even further and machine around our part. Now, something else to keep in mind here, I don't know who designed this with 2 different size Mighty Bites or if something got moved, Elijah. But as you can see, again, this is a neat thing that's happening in real time is because The mighty bite itself is sticking up. Who knows why? Blame the engineer, always. Even then, my fixture avoidance is coming in and saying, hey, this is in the way. Let's stay away from it by 50 thou. Now, one problem with using component pattern, right? As you guys can see on Elijah's setup, he has 1, 2, and 3. And if we go ahead, I'm going to go ahead and jump back to design because it'll be easier to see. But all of them are facing identically the same direction. But his mighty bite spacing is only identical across 2, not all 3. So this is just something where, again, maybe you rotate this third one 180 degrees and fix your mighty bite. This reminds me, maybe we should start a roast my toolpath segment, right? But anyways, as you guys can see, I just want to point that out because if we start to look into our component pattern for toolpaths, you're going to notice that we are avoiding this mighty bite. If this mighty bite was sticking up, we would be machining it off, right? So again, based on this one here, it's even doing that avoidance. So this is where we get into that argument. What is the better way to do it, Fusion Phil? Should I use component pattern? When is it valuable? When is it not? Well, first, design your jig right? Just kidding, Elijah. I'm going to go ahead and ditch the component pattern. I'm going to move my toolpaths out of there. Let's delete it. And then what I'm going to do is I'm going to change my setup. So again, this is where we can go through and do a completely different thing. I'm going to make an assumption here that in Elijah's case, he's using a 0-point fixture system, which would mean he's probably using bottom center on a lug somewhere that is a known reference position, right? Now from that, I can just triple up everything I've done. So again, this is a neat trick that when you're trying to get something into production and you're trying to duplicate stuff, it's always easier to work on one part than it is to go through and work on all 3 simultaneous. But that means in the world of Fusion, we need a to and a from based on 3s. So again, we need 3 parts, which means we need 3 stock. Mighty Bite is lower in real life. That's good. I'm glad to hear that the Mighty Bites ended up where they should have been. So again, as you guys are seeing me do here, I'm going to regenerate my toolpath. Now we are getting a little bit of wasted cycle time and we can fix this. This is where we get into the technicalities of why it is important to machine one, get a perfect part. Let's transition into how much fun we can have utilizing something like production machining. So again, I'm going to go in. We are working with separate stocks, not a bounding box of stock. So this is where something quick like face contour, we're going to go ahead and turn on our stock. Again, we're going to go ahead and pick each face. And as you can see, I've now made my 3 separate stocks come through. And now we're still getting about the same toolpath, but the goal is to limit really how much it's going to do, right? So again, if we wanted to, instead of using our facing profile, this is where you might actually say, you know what? My stock is smaller than my face mill. Let's do 2D contour instead. I'm going to go ahead and pick this side here, here, and here. We're going to go ahead and flip direction on these. And then what I'm going to do is I'm going to use now stock to leave to bump myself over to the right just a little bit. So again, stock to leave, minus 250, 0 axial. And now we're just making 3 clean passes down the center, right? So again, this is a little different way to speed up your production and get a much faster cycle time. So again, we could go down. Now we're going to look at 3D adaptive clearing. As you're going to see on 3D adaptive clearing, I'm going to have to regenerate this again either way. If I reorder my 3D adaptive clearing again, Elijah, is avoiding this mighty bite, but that's more than okay, right? So again, as you're seeing, when we get into the world of doing things with 3D toolpaths, it tends to work much better for you. Now, something else that would work really, really good, let's get this all limited back up so that you guys can see this, is when we start talking about, you know, do I use 3D for finishing? Do I use 2D? Again, everybody is different. Every scenario is different. As you guys are seeing me do here, maybe inside this case, I'll go through and I'll say silhouette of each part instead. I only want to do the outer loops, not those inner circles. And as you guys are seeing, this is the value of getting things set up correctly or being able to self-determine what it is that you need, right? So again, fixture top is how far down I want to go. I want to stay above the fixture top 025. And just like that, using silhouette, instead of using a selected edge, I'm quickly creating those toolpaths. So Elijah, what's your questions that you really have about these parts? Because I assume they're not about the backside, right? They got to be about the front side. I do know these are made out of 303 stainless, as I'm hearing. Now, in my case, if I was working with a little bit more of an exotic material, whether or not it's bigger or smaller, I may change up how I do this adaptive clearing versus pocket clearing by all means. So let's go ahead and create our second setup. I am going to treat this as in we are only doing one of these guys on the flip. Let me get back into our design tree and pick just that first lure. Again, from preceding setup is going to be a little brutal here because, again, in our first setup, we picked all three models. In our second setup, we're trying to only use one, which is going to leave us with stock times 3. So we'll get that fixed here real quick. Again, just for demonstration purposes, we're going to go ahead and go back to the system of 1. I know I've been doing a lot of jibber jabbering to most of you out there about, hey, you could do this, you could do that, use this pattern, use that pattern, right? So again, now our rest machining should come through much better. Obviously, we need to flip our Z-axis again. And just like that, that's what we're left with working. Now, again, I could probably take my adaptive clearing. I'm just copy and pasting it with Control-C, Control-V. And just like that, we're now roughing back the other way and creating that profile. Now, Elijah, the question would be is, do you have any machining extensions? Do you not? Things of that nature. If so, or if not, buy it from me. Send us an email. We'll get you a quote. So you do. Awesome. Perfect. Did you know you can also renew that stuff through us now? We've figured out a way when your renewals due, let us know. We'll get you moved over to JitCAD Cam. So right off the rip, there's a lot of things you could do to this. Now, you guys have just seen me do the whole concept of the derive a lot, right? So this is where, regardless of kind of where I go in the world of 3D toolpath, I'm going to start with scallop, swap out my tool. I'm assuming you're using a ball end mill. So let's go ahead and get us a nice ball end mill. And again, we can leave this as default, but each toolpath that I start to go, he has next gen. There's nothing wrong with next gen, guys. They're a great company. I used to work there. Obviously, much better to come over here to this side of the fence. But as you can see, something like a scallop toolpath works really, really good because it tends to offset your passes based on the outermost boundary. Now, I do need to fix this a little bit. As you're going to see, as I'm going to go into my scallop, and with you, you're going to see, Elijah, you can still go with us. It's not a big deal, man. We have your contact info. I'll tell Heidi to come over and get your licenses moved. So as you guys can see, we have our silhouette, tool center. I'm going to go ahead and kick on contact boundary. If you guys did or did not know this, this is going to go ahead and shift the center line of the tool, which is what's happening on my tool path, right? We get to center line of the tool and it just stops. We're not fully going down around that fillet. So again, one little simple change. Now we do need to go back and make one more change because we're going way too far now, which is going to be, we don't need a boundary overlap. We're kind of just doing a one and done. And again, based on the radius of the tool, at some point we get down here where we start to make our vertical passes and it cuts us short. Now it may also be cutting us short down here on the tip. So this is also something for you guys to keep in mind. Let me get over here where it's not behind my big old head. Because of our heights boundary, that is going to leave us in a bad situation. So again, Elijah, I don't know how you're machining this. An easy fix if I wanted to stay with that large end mill. Let's go ahead and drag our bottom height down a little bit. And as you can see, we're now wrapping down and around, so forth and so on. So again, a scallop toolpath could be very, very beneficial in a situation like this. Now, the reason why I want to show you guys this is because even though we've gotten this scallop toolpath, let's go ahead and do a few things. This is why we can quickly pivot with derive again. Let's go ahead and do a parallel path. As you're going to see, we can see which direction our parallel is going. This might be the token, right? A few other things, as you can see, is I'm going to go ahead and switch from manufacture back to design. But in the event, let's get these all popped back out here. I'm going to go ahead and do an isolate for you guys. So this is the one we're working on. Now I'm going to apply a patch over these two holes. And as you guys can see, that is going to make my toolpath much cleaner and faster when I start to work on these different strategies. So again, we could go model, pick those two patches to add, including our setup. And now you're going to notice we're not dipping into those areas. So I'm adding that on there temporarily as we go. So as you can see, I don't know what's going on in this chat anymore, but we're up to 22. So as you guys can see, again, the idea is when you're doing something like this and you have questions about surface finishes, is you can quickly, as soon as you kind of get one figured out, you can play the game of pick and choose and which one's going to be the right one. Now, when you get into some of the other toolpaths here for 3D finishing, you're going to notice that you're going to change gears from being a boundary to a surface-driven scenario. So again, as if I was to go blend in this case, as you're going to see, it's going to want drive surfaces. So this is where I could go around the outside of this part and pick those surfaces. Now, blend is designed for external fillets, right? So as you're seeing, it's the perfect solution going around this part. Now, I do need to give this drive curves as well. As you can see, I can pick my lower rail. And just like that, we're going to go ahead and blend around that part. And what that might work out better than scallop everywhere, right? Maybe we only do the scallop toolpath in a selected area. And this is my selected area. And again, I'm going to go ahead and throw those surface patches in here this time around. So again, there's my two surface patches since we didn't have them. So now we're doing a scallop toolpath specifically in that actual bigger, flatter, shallower area. And then we're doing a blend toolpath to clean up that outside fillet, again, giving us those nice clean lines around our part. Now, again, there's no right or wrong here. We could have, of course, tried something with something like geodesic. If this is a new toolpath that you've never touched, Brian, I'm going to get to that in a minute. But as you're going to see in geodesic, the luxury of geodesic is the fact that it is really aimed at weird, shallow surfaces, right? So as you can see here, this is kind of a weirder, shallow surface. Now, he's not flat. He is flat, but he's not flat in a 3-axis environment. So that being said, as geodesic could be extremely handy. So again, geodesic, if I pick my toolpath and have no idea what I'm doing, I'm going to go ahead and hit OK. It's now asking me what is the surface I want to machine. And as you're going to notice now, we have different types of passes, right? Scallop, blend, again, kind of the same as what you've done so far, but we can up the ante here. And this is why I like it, because we could either use the boundary, which would be the outermost edge, or we could create lines, circle, curves. We could select a curve that we want to follow for that toolpath to replicate off. So again, as you guys are going to see here, we're going to go ahead and give this our two patches as well. And we're going to make sure that it knows that is part of the model. And again, at the simplest level, there is a scallop profile running back and forth. Maybe instead, I want that surface to look more like a blend. So again, this is going to be night and day difference for a lot of you where you realize I can't use blend because blend is more of a walls and fillet strategy, right? So just like steep and shallow, this toolpath does have the ability to only kind of stay in one or the other, kind of like you guys saw me do with multi-axis finishing, right? There was a walls versus floor strategy. So let's do steep and shallow. So I'm going to go ahead, go back to this parallel. It's the only toolpath I don't think I've butchered so far. 3D, steep and shallow. Again, luxuries features right here is based on 30 degrees. We're going to switch from what's more or less going to be contour or ramp into what would either be scallop or parallel. So again, as you guys can see, we can change our step down versus a completely different step over. And just like that, we've kind of done it all in one, right? So once we get over to these edges, you're going to get some nice blending between the changes in profiles. Even the top, again, we still get that nice scallop strategy. but I'm doing this all with the same confines of getting blue lines where I want them first, and then just deriving everything else off of it.